Good evening, everyone. My name is James Edwards.
And I'm Melanie Lothan.
All right, this evening we'll be doing tutorial 5, question 2, parts A and B. We'll be doing part A using two different techniques. Melanie will be starting off using the present value table, and I will be following up later on using the bond value formula. Melanie?
Thank you, James. All right. The part that I'll be doing states, first let me read the question. The select company has two bond issues outstanding. Both bonds pay $100 annual interest plus 1,000 at maturity. Bond L series, a maturity of 15 years, and Bond S series, a maturity of 1 year. What will be the value of each of these bonds when the going rate of interest is 1, 5%, 2, 8%, and 3, 12%? Assume that there is only one more interest payment to be made on the bond S. All right, here we go. All right, first we're given the value of the bond. The formula is coupon interest multiplied by the PVIFA interest and number, which stands for N, plus par value times PBIF interest N. The value of the bond L is $100 as stated in the question, and the present value interest factor annuity is 5% at N, which is 15 years, and $1,000 for the par value. So I use the table to find what the present value interest factor annuity of 5% at 15 years is, which will give it a 10.3797. And I use the present value interest factor table, which gives you the 0.481. So therefore, the $100 times the 10.3797 plus 1,000 times the 0.481 will give you $1,037.97 plus $481, giving $1,518.98. That's for bond L. For bond S, same procedure, but because we were given a 1 year period, we change it to a 1 year period at the same 5%. Okay, so it's 100, use the same table. The present value interest factor annuity at 5% for 1 year, it gives you 0.952381, and present value interest factor 5% at 1 year gives you 0.952381. So $100 times the 0.952381 plus the 1,000 times the 0.9581 gives you a total of 1,047.62. So that's the part for the 5%. Next, now we have the section bond L at 15%, 8% at 15 years. So what we're doing is, for each percentage given, is plugging it where necessarily and finding the value on the formula, on the table. So here we have the 8%. We use the 8% at 15 years on the table to give us the present value interest factor annuity value and the present value interest factor. So this is where we have the values 8.5595 and 0.3152. Add those together, you get 1,171.15 for bond L. Value of bond S, same procedure, use the 8% at 1 year to find the values on the table, multiply them, the 100 times the factor that you get from the table, add them together, and this is the result. Same procedure at the 12% rate for the 15 years. You look for the value in the table, present value interest factor annuity at 12% for 15 years, and plug in the values, and you would get the 863.79. Bond S, you use the 12% at 1 year, and Find the values in the table, total them, and you should get 982.19. I now hand over to James.
Thank you, Melanie. We will now be doing the question using the formula. Just give us 1 second as we transfer or change that document to the one we'll be using now. So the question remains the same, but this time we'll not be using the table, we'll be using the formula. In this formula, we see the bond value equaling the coupon rate times 1 minus 1 upon 1 plus the interest rate raised to the year of maturity divided by the interest rate. And then we'll add that to the face value divided by 1 plus the interest rate raised to the years to maturity. In this question, we'll be identifying the coupon payment as C, $100, the interest rate are 5%, the face value 1,000, and as it relates to the year of maturity, we'll be having 15 years for the L bond, the L series, and 1 year for the S series. So let's start. When plugging in the values, we will be getting a calculation showing that we'll have 100 times 10.3797 plus 1,000 divided by 1.05 raised to the 15. This is calculation you'll be able to do using your calculator. I just encourage persons to do it in separate stages. The result for the first one, for the long-term series bond, will be $1,518.98. We'll be replicating that in the short-term series. In this case, we'll have T being 1. Any number raised to the first power is just a number, so let's go. When we do this, we will have 100 times 0.952381 plus 1,000 divided by 1.05. Those results will produce a figure of $1,047.62. We will be doing the similar application for part 2. Only thing this time we will be using the interest rate at 8%. So R in this case will be 0.08. We'll be using it as a decimal, not as a whole number. So we'll be getting the first part of the calculation to be 100 times 8.5594, and we'll add that to 1,000 divided by 1.08 raised to the 15. That will give you a result of $1,171.18. Similar application for the 1 year short-term series, where we'll have results of 100 times 0.9259, and we'll add that to 1,000 divided by 1.08. The result will be $1,018.51. We'll be going on to the 12% interest rate, and same procedure, just plugging them into the formula, and that will have results of 100 times 6.8108 plus 1,000 divided by 1.12 raised to the 15. The result, $863.77. And that's for the long-term series. For the short-term series, we'll be having T equaling 1, the year to maturity, and the results will be 100 times 0.8928 plus 1,000 divided by 0.12. Total result, $982.14. So we can see that it doesn't matter which one of the applications you use, the results will be pretty much identical. In this case, we're just off by a couple cents through rounding errors, but this would have been the result. We'll now start doing part B, and I'll just start with my part. Part B was asking about the explanation as to why you would have, fluctuations with different periods, different years to maturity between both the L and S series bond. And that is simple. And this we can just say the long-term bond will, fluctuate more than that of the short-term bond due to the interest rate risk. As such, the longer the years to maturity, the more sensitive a particular bond will be towards interest rate, as highlighted in part A of this question. And Melanie will now be taking over for part B. All right, Mel, look like we have got to start over because you're mute and if you say you talk and you're mute, but I'm not saying nothing still.
Okay. So in addition to what James had said in his explanation for part B, we also have long-term bonds would vary most. Interest rates increasing mean that your opportunity cost is increasing. A longer-term bond is more sensitive to inverse change. The longer a bond takes to mature, the more the interest rate as opposed to a short-term bond. Therefore, is an inverse relationship between price and the value of a bond. This is the end of our presentation for question 2. If there are any questions, feel free to ask so we can clarify. Thank you.
Thank you, Melanie and James. We're now going to hand over to Kimberlyn and Bethany, who will give us their perspective on the solution for this question.
This is question 2 of FINMA tutorial sheet 5, which will be done by Brittany Craig and Kimberly Davidson. The question states, the select company has 2 bond issues outstanding. Both bonds pay $100 annual interest plus $1,000 at maturity. Bond L series has a maturity of 15 years and Bond S series has a maturity of 1 year. What will be the value of each of these bonds when the going rate of interest is 1, 5%, 2, 8%, and 3, 12%? Assume that there is only one more interest payment to be done on Bond S. All right. The formula states that BB equal 1 bracket 1 minus 1 divided 1 plus I to the nth power divided by I plus power value bracket 1 plus I to the nth power. In this case, I will be equal to 5%, 8%, and 12%. N for the Bond S series will be equal to 1% to 1 year, while N for the 15-year series will be equal to 15 years. M, our par value, will be equal to $1,000 and $1,000 will be equal for payment. In this case, Bond S series rate of 5% will be equal to $1,047.62, where it shows that $100, the payment, bracket 1 minus 1 divided by 0.5 to the 1 power divided by 0.5 plus 1,000 divided by 1.05 to the 1 power, which be equal to 1 bracket 1 minus 0.95 bracket divided by 0.5 plus 952.38, which be equal to 952.23 plus 952.38, which be equal to the grand total of 1,047.62 cents at maturity. For the rate of interest for S series of 8%, it will be equal to $1,018.02, where the same formula is presented where only the I value change of 0.8. For the 12%, it will be equal to $982.14, where the I also changed to 0.12. For the L series in comparison to the S series, at 5%, the rate of return will be equal to $1,518.98, we're using the same formula, while the 8% will be equal to $1,171.19. And 12% will be equal to $863.78. I'll now hand over to Brittany.
Okay, so I'll be doing part B. So part B says, why does the long-term 15-year bond fluctuates more when interest rates change than does the shorter term bond? So the long-term bond will fluctuate more when the rates change because of the fair value of the bond will change as the rate increase over the years. As for a short-term bond of 1 year, it will only have one interest rate before the maturity date. Generally, bonds with long maturities and long coupons have the longest duration, and these bonds are more sensitive to a change in market interest rates and thus are more volatile in a changing rate environment. So the reason for that the long-term bond has greater interest rate sensitivity is that a large portion of the bond value comes from the par value and the face value amount, which is $1,000. This is the end of the presentation. Thank you.
Thank you, Kimberlyn and Bethany. So just to wrap things up, for the 15-year bond, we can see that the value at 5% is 1,518.98. At 8%, it drops to 1,171.19. So that's a $347.79 drop for a 3% increase in the rate, as compared to for bond S, the 1-year bond. For a similar increase in the rate, the value drops by about $29.10. All right, so similarly, when the rate further goes up from 8% to 12%, the 15-year bond drops by $307.41, while the 1-year bond falls by $36.38. All right, so the question is why? Let's going back. Why does a longer term 15-year bond fluctuate more than the shorter term bond? And the answer is where we bring in the time value of money. So for the 15-year bond, the interest plays a significant rate because it's acting over a 15-year period as compared to just 1 year for the other bond, for bond S. right? The par value, for example, for bond L is 15 years away. So with an increase or a change in the rate, there's going to be a much more significant fall in the value as compared to bond S, which is just 1 year away. Right? So this really comes down to simply the time value of money. Right? And you'd have gotten all the other explanations. So I hope that everybody is good. And I wish you all the best. Our next videos will be related to tutorial sheet number 6. All the best. All good.